Fermentation process. The fermentation process for beer includes sourcing material, malting, mashing, and lautering the material, and allowing yeast to feed on the sugar and to convert into alcohol. After fermentation, brewers have a series of additional options to decide on. Main ingredients. Beers can be brewed from a plethora of ingredients. That said, most productions of beer are centered on the use of either raw barley, wheat, oats, or rye. The reason for these particular grains is believed to be in association with hunter-gatherers transitioning into more agricultural lifestyles. Malting. Once the materials have been decided and sourced, they must be germinated in a malt house. From there, the grains are taken to a separate location where they are dried in a kiln and are sometimes roasted. Over to the brewery, the malt is put through a grist mill where the kernel husks crack open and expose the necessary starches in preparation for the mashing process. Another option for larger scale brewers is steep milling, which is soaking the grain before milling. The term grist mill refers to when a brewer utilizes a recipe of different grain types to produce their beer. Mashing. Once the materials have been malted, the mashing process is the first step in beer making. During this stage, the grist is transferred to what is called a mash tun, which is an insulated vessel where the crushed grain starches are converted into sugars. The grist is combined with water and heated, typically by steam, to between 100 to 170 degrees Fahrenheit. This mashing process is what causes the natural enzymes in the malt to break down these starches into fermentable sugars. During this process, certain proteins are also released that are responsible for the formation of foam in a finalized beer. There are two ways in which the water can be added to the grist: infusion or decoction. With infusion, the grains are heated in the mash tun. In decoction, a portion taken from the mash tun is transferred to a separate mash kettle where it is boiled before being returned back to the original mash. Brewers can choose to repeat this process twice or even 3 times: double decoction and triple decoction. Lautering. During the next step, the mash is pumped into a lauter tun, where the wort, sweet liquid of sugar and water resulting from the mashing process, is separated from the grain husks. Boiling. Once the wort is collected, it is boiled inside of a kettle for 60 to 120 minutes in order to sterilize it. It is during this time when hops are added to the liquid. The hops are responsible for attributing flavors and bitterness to the finished beer, depending on which point during the boil the hops are added. Hops added earlier in the boil will result in more bitterness, while hops added later in the boil will increase flavors and aromas. Cooling, also referred to as the whirlpool stage, once the wort has boiled, it is then transferred to a whirlpool, where the separation occurs, removing trubs, solid particles from the hops, and proteins. While a standard whirlpool is more efficient at collecting trub, a hopback is a certain type of whirlpooling vessel that filters the trub by utilizing fresh hop flowers or cones within a sealed chamber. These are often implemented when whole hop cones are included in the boil. The result of using a hopback is an increased amount of hop aromatics within the wort. After that, a heat exchanger reduces the wort to the necessary temperature for fermentation to begin. This process results in heated water, which the brewer typically uses to begin a new brewing cycle. Fermentation. The wort is then transferred to a fermentation tank where the yeast is added. Yeast is a single-celled microorganism that exists in many different strains, with no two being exactly the same. Each yeast strain imparts unique congeners, the impurities produced during fermentation that result in certain flavors and aromatics. During fermentation, the yeast converts the wort sugar into alcohol, primarily ethanol, and produces both congeners and carbon dioxide. Carbon dioxide is the component that is responsible for the natural carbonation in beer. Conditioning. After fermentation is complete and its byproducts begin to dissipate, brewers have several different options to select while the beer continues to balance out and mature. In total, this stage can last from 1 to 6 weeks, in some cases even longer. Dry hopping. This is the process of supplementing secondary hops in order to add further hop aromas to beer. Certain styles call for this step, including pale ales and IPAs, but it can also be implemented for other styles of beer as well. Barrel aging. After fermentation, the young, green beer often needs to be matured to maximize the complexity of flavors. This process also allows the beer more opportunity to develop a smoother finish. Filtering. Brewers have the option to filter out any remaining yeast or other particles, depending on the style they desire. Pasteurizing. Brewers also have the option of pasteurizing their beer. This process improves the beer's clarity and can also increase the total shelf life. Carbonating. Depending on the preferred style, carbonating can influence several factors in the finished beer. It imparts body and mouthfeel, boosts the beer's appearance and head retention, and can also increase aromas from hops and malt. That being said, not all beers are carbonated to the same exact level. The level of carbonation is measured in volumes of CO2. One volume is expressed as a given volume of dissolved gas in the same volume of liquid. For example, 1 volume of carbonation in a liter of beer would equate to 1 liter of CO2. Beer is typically served between 2 to 3 volumes of carbonation. Cellaring. After all selected conditioning processes have been completed, the beer is transferred into a bright beer tank, a pressure vessel used for the storage of beer. Brewers usually allow between 3 to 4 weeks of cellaring before their beer is bottled and packaged.